Welcome to Ask and Learn.
All right, for this problem, we're going to use the definition of gravitational potential energy, which is U equals negative G times M times small m over R. R being the distance between the two objects and between the two centers of mass, and M being the two masses. And so here we equate energy at the ground, so that would be kinetic energy at takeoff of the rocket. It's called that K sub R, plus potential energy of the rocket at the surface of the Earth. So R will be radius of the Earth, and that will equal, assuming no air friction, that will equal potential energy at a height h above the surface, called that U sub h. So this is 1/2 mv naught squared, v naught being the velocity, the launch velocity of the rocket, plus negative, because that's u, negative g times big M is the mass of the Earth, small m is the mass of the rocket, same as this m, over r sub e, that being the radius of the Earth. That is equal to a negative gme times m over, this time it's radius of the Earth plus the height above the ground, so the rocket reaches. Okay, and so we notice immediately that the small m's cancel, which is good. We don't need to worry about the mass of the rocket, which is not given anyway. And so we have 1/2 v naught squared equals gme over re, minus gme over re equals negative gme over re plus h. Okay, so we want h, and so for that we need to do a little algebra here. We have 1/2 v naught squared equals gme as common, taking that as common and pulling this term out to the right hand side, so it becomes a -2. So it's multiplied by 1 over re, and subtract 1 over re plus h to that one, and this is what you have. Okay, then do one other thing now. So 1 over radius of the Earth, minus 1 over radius of the Earth plus height will be equal to, I'm just pulling out the gme to the other side, will be equal to v naught squared over 2 gme. Okay, and then you have 1 over re plus h equals that term, negative v naught squared, or looks like, right, so you have negative v naught squared over 2 gme plus 1 over re, and the reason this term becomes negative is that we're just pulling 1 over re plus h to the right hand side, to the other side again, and v naught squared over 2 gme to the left hand side, right, with 1 over re term. Okay, and so this looks like a not an easy task to pull out just the h, and so what we're going to do is we're going to inverse both sides, and what we have is re plus h is equal to 1 over re minus v naught squared over 2 gme inverse, and therefore h, just h, the height, is all of this stuff, 1 over re minus v naught squared over 2 gme inverse minus re. Okay, and there are other algebraic simplifications you can do, but this will honestly do. All you have to do at this point is plug in values, and be careful when you're using the calculator. And so what you have is 1 over re. So re, radius of the Earth, is about 6,380 kilometers. So 6,300, well, 6,380 kilometers. Therefore, it's that times 1,000 meters. So that's 6.38 times 10 to the 6 meters. Okay, 10 to the 6 meters minus v naught squared, rate velocity of launch. That's 850 meters per second squared over 2 times g, which is 6.67 times 10 to the negative 11 in SI units. You don't need to worry about the units if you use that, times mass of the Earth, which is about 5.98 times 10 to the 24 kilograms. By the way, this information is all in the book, or you can look it up. Everyone knows the mass and radius of the Earth, so you know these quantities, and so you inverse that, and you subtract radius of the Earth, which is again 6.38 times 10 to the 6 meters. So very careful when you're plugging these into the calculator. And so what you end up getting is that the height, the maximum height to which it can rise is 3.708 times 10 to the 4 meters, or 3,708 kilometers. And I think that is it. And yep, look like that is it.